Welcome back. Now we'll look at the final paper of the May-June 2024 series. This is paper 23, and of course the mark scheme has been released already. So as well as watching this video, I would also recommend checking the mark scheme. Just seeing what additional answers they also give. And of course, as always, if the video is too slow, then 1.25 or 1.5 times the speed is recommended. Right, it says refer to the insert for the list of pseudocode functions and operators. Right, then a program uses many complex algorithms. One algorithm is repeated in several places. The code for the algorithm is the same wherever it's used, but the calculations within the algorithm may operate on different data. Right, the result of each calculation is used by the code that follows it, and it's decided to modify the program and implement the algorithm as a separate module. Okay, then we want to state two benefits of this modification to the existing program. So really this is just asking, what's two benefits of using modules? Because if we say here what we've got this repeated code, yes, as the code is the same, but I guess the algorithm may operate on different data. So this is saying we can use a different parameter. So I guess one benefit is let's say less repeated code. And then we can say hence, hence shorter program and easier to understand. I guess we can say sort of fewer lines in the program. But I think shorter program is okay. Hence easier. Easier for programmer to understand. Because of course, if you've got a program with say 500 lines, that's going to be easier than if you've got 2,000 lines. Right then, I think the next one, because we have less repeated code, then of course that means that if we want to make changes, then we only have to change it in one place. Let's say, maybe if code is organized into modules. Organized into modules. Let's say, then any changes. And for changes, we can give three examples. So we can say perfective, if we're thinking about the different types of maintenance. So perfective just means kind of improving the code, right, making it faster, making it use less memory. Then there's also corrective. So corrective is about fixing bugs, right? So if there's some error, of course fixing that. And then also adaptive. And adaptive means if let's say the program requirements change. So maybe you're making tic-tac-toe, right, noughts and crosses, and initially you might have it where you just want a 3x3 grid, but let's say now you want to kind of modify it where it can be an n-by-n grid, right? So the user can choose I guess either they can choose 3x3, right? They can choose 10x10. Right. So if code organized into modules, right, then any changes, right? Let's say only have to be made in one place. And obviously that, one is going to be quicker, but I think most importantly, it's actually going to be less error prone, because if you've copied the same code in 20 different places, probably you're going to sort of forget to change one of them. Especially when you have many different files, thousands of lines of code. Right, then describe how the modification would be implemented. So I think here, because they're saying the result of each calculation, it's saying the result is used by the code that follows it. So this is saying we're going to have let's say something like A. Maybe we have some function called X, right? That's going to take it B, C as parameters. And then of course, we're going to use this for some D calculation or something. So what we're saying is, we can create a function, right? This function will take parameters, and then the result of this function will then be assigned right back to this variable. So I think that's kind of what we want to explain. So let's say, right, we can create a function. Let's say, we can create a function that takes parameters. And maybe we can explain that, right? Let's say in order to let's say what, in order to use the function with different input data. Yeah, okay, with different, yeah, let's say different input data, I think that's fine. Right, so we've said, yeah, it's going to take parameters, and maybe we can say, right, and copy the original algorithm inside this function. Yeah, okay, and let's say maybe and copy the code, right, for the, yeah, let's say for the algorithm inside this function. Okay, and then I guess we can say, well, you know, when we actually need, when we need to use this code, you know, we need to call this function. Right, so let's say, yeah, the function can be called when needed. And then let's say, well, and the result will be returned, yeah, to the variable that we're assigning it to. Yeah, let's say, right, and the return result can be assigned to a variable. Okay, right, yeah, can be assigned. Right, yeah, to a variable. And yeah, hopefully that's enough for 3. Right, 4 of the expressions used in the program are represented by pseudocode in the table. Complete each pseudocode expression with a function or operator so that it evaluates to the value shown. Right, any functions and operators used must be defined in the insert. So if we just have a look at the insert, and again, I guess, well, the way you can find this, like if you just search, let's say 9618, right, that's the syllabus code. Yeah, well, 9618, like unit 2 insert. And yeah, you should be able to find this online, you know, quite easily. Ryan, yeah, let me just split screen so I can see both of them. So if we look at the first one here, then, well, it's going to take, what, 3 arguments or 3 parameters. The first is going to be a string, right? Then we've got, well, obviously 2 integers. Now, I mean, this one, hopefully you, yeah, I guess hopefully you would remember if you're familiar with this. Well, yeah, if you're familiar, you know, with these functions. But if we look, well, I mean, the one that's going to take these 3, and if we think, well, it's going to evaluate to and, so we can probably see what and is going to be basically this substring. So yeah, therefore that's going to be this one, right, this mid. Okay, that takes a string, right, and then here's, we see it takes 2 integers. Okay, yeah, I'm not sure why that's not working. Alright, yeah, I think I'll just ignore that. Alright, so yeah, this one then is going to be mid. Right, the next one we want to think, well, 5 plus something, that's going to take in this date, and that's going to return 15. So we think, well, it's going to be 5 plus 10. Now, 10, of course, is, well, it's going to be the day, because if we think, right, this is going to be what, yeah, day, right, then it's month, then obviously year, like this. Yeah, that's going to be the format of dates. So we then just want to look, well, what's going to extract the day from the dates? And yeah, that's going to be this day function right here. Right, then the next one, so it's going to take in, well, let's say a numeric string, and it's going to return true. So in order to do that, well, let's go up here, look at these string functions. And I think there's one called like isNum. Or yeah, maybe they put that on the, okay, yeah, here we go. So we see isNum, well, this takes a string parameter, then it's going to return a Boolean. And it's going to return true if the string represents a valid numeric value. Yeah, okay, and then, right, so the data type may be char or string. Then, of course, it just gives us some examples. So yeah, this one is therefore going to be isNum. Right, then the last one, well, 20. So what, 20 something plus 1. Right, hang on, so yeah, 23 plus 1 equals 3. Okay, so I mean, obviously, like, we can't use minus because that's going to be 17 plus 1 is 18. So, I mean, let's think about maybe div or mod. Now, if we have 20 div 3, well, 20 div 3 is going to be 6. So for 6 plus 1, that's 7. But then let's try mod, so 20 mod 3. Well, I mean, basically, if we divide it, it's going to be 18, right? And then 18, of course, gives us 2 remaining. So, yeah, I think if we use mod, right, 20 mod 3 is going to be 2, therefore 2 plus 1, right, that's going to give us this 3. But again, you know, it's good to be familiar with these, with these functions that they give you. So I'd recommend reading the insert at least maybe, I don't know, sort of 1 or 2 times, right, maybe more, if you need to. Right, the next one, a program uses a global 1D array of type string and a text file, and an algorithm that forms part of the program is expressed as follows. Right, it will copy the first line from the file into the first element of the array. Then it will copy the second line from the file into the second element of the array, and continue until all lines in the file have been copied into the array. Right, it says stepwise refinement is applied to the algorithm. Outline 5 steps for this algorithm that could be used to produce pseudocode. Right, assume there are more elements in the array than lines in the file. Okay, so yeah, do not use pseudocode statements in your answer. So I think for this, like, rather than just sort of starting to write, because honestly, like, often if you start writing on these, you know, you'll probably, I don't know, like, maybe you only think of 3 steps, or maybe you only think of 4 steps. Right, then of course you have to go back and try and add more. So I think, yeah, first let's try to think of the 5 steps. So if we have any sort of file question, I mean, well, I guess the first thing we can say, maybe we're just going to open the file. And of course, we're in pseudocode, that's going to be openfile. Right, then once we've opened the file, I mean, obviously, like, we're going to need some sort of index in determining, you know, what position we're writing to in the array. Because obviously, while the first line is written to the first, you know, the first index, obviously then we're going to sort of increment, right, the second line is, the second index. So we could just say, right, I'm just going to say like init, right, so initialize. Then we could say maybe read file. Or we could, let's say like read file in a loop, right, so sort of continually read the file, right, while the file is not empty. I guess, right, once we've then read the file, and we would obviously read that into a line variable. Then I guess what we just want to copy the data. So I guess maybe just assign. Let's say assign data to the array. And then I think finally what we can probably say closefile. I mean, so that's 5. Like, I think I'm going to go with those 5. Hopefully that's okay. Right, so let's say the first one, just open, and we only have, just one file. Right, open the file, for reading. And I think here it's going to be important to say the mode, right, whether it's for reading, for writing, for appending. And of course in pseudocode we just go, well, open file, right, then the file name, then we say for, and then, well, read. Of course if we're writing we say for write, or for append. I think that should be okay, right. Then we want to say initialize. So I suppose what we could say declare, right, maybe declare and initialize. Although maybe we don't need to say declare. Right, let's say initialize an array index variable. And I suppose, one thing we actually didn't mention incrementing. Maybe we can sort of combine that into... I mean, I don't know, like, maybe we can combine the increment sort of with this assign. Or we can just add, I don't know, maybe we can add step 6, right? I think if you have more steps, I mean, that should be okay, because, I mean, like, well, as long as 5 of them match the ones in the mark scheme, then I think it's okay. Right, so declare and initialize an array index variable, let's say, well, to the value. Now, this depends, because if we increment before we assign to the array, well, then we can initialize it with 0. Right, if we increment after we assign to the array, well, then we'd have to initialize it to 1. Of course, so that it adds, into index 1 here. I mean, let's just say, I don't know, let's just go to 1. So we can, like, do a post initialize. So initialize after the assign. Right, let's say, I don't know, create a loop. Right, let's say to continually read the file while empty. I guess while not empty. And I think we can say what and perform, let's say and perform steps 4 to 5. Because yeah, obviously 4 to 5 should be inside the loop. And yeah, let's say while the file is not empty. Or I guess we can say what while there are lines remaining. Right, then what we want to do, I guess what we can say, maybe increment the index variable and assign, yeah, let's say and assign the line to this, I guess what this index in the array. Yeah, let's try and write that. So, okay, yeah, increment the index variable. Right, and let's say, yeah, and assign. Yeah, okay, assign, let's say the red content okay, yeah, let's say the red content right into this index in the array. And then I guess, yeah, well, then we can just say close the files, or well, close the file. Yeah, so hopefully that should be okay. Right, then it says sequence is one programming construct. Identify one other programming construct that will be required when the algorithm from part A is converted into pseudocode and explain its use. Right, so I guess, I mean, other constructs, what you can talk about iteration. So either iteration, I guess you can also mention selection. So, I mean, iteration we have because, of course, we have a loop. I mean, do we have selection? Yeah, I mean, I think for this we wouldn't need any if statements. So, I mean, here, well, let's mention iteration. And actually, like, yeah, for this question it's a bit strange because I think they do actually want the specific type of loop. So let's say what a count controlled, and then we can put in brackets a while loop. Because obviously here, I mean, you can't really use a for loop because, well, maybe the file has 3 lines, maybe the file has 100 lines. Yeah, obviously we don't know how many lines the file has in advance. Right, and then the use. So what I guess maybe here they're saying just to loop through all the lines in the file. Or we can say what to loop. Let's say while a condition is true. So I mean, obviously, yeah, this is the general use. And let's say what e.g. or yeah, i.e. Let's say well, while the file has lines remaining. Or yeah, maybe let's say well, while not at the end of the file. So for these kind of questions, like it's often good to give, let's say like a general sort of definition, and then yeah, also give the specific example that's relating to this particular question. Number 3 says a record structure is declared to hold data relating to components being produced in a factory. Right, so yeah, we've got this type, right, record component. That's kind of an item ID string, right, reject boolean and wait is real. And yeah, hopefully people remember this syntax for declaring a record. Right, we just say type, right, then of course the name. Yeah, then we just have the declarations, right, just standard declarations. Then of course just the end type. And I mean, you think, well, like everything in pseudocode, for example, like if, end if, right, for has the next, yeah, repeat has until. So obviously, yeah, if you sort of have some like opening, let's say opening keyword or opening statement, you also need to remember to have the closing. Same just like open file and then close file. Right, the factory normally produces a batch or a set of 1,000 components at a time. A global array is declared to store 1,000 records for a batch. Yeah, okay, and again, right, make sure you're using this syntax for declaring arrays, because I've seen some people using slightly different syntax, where, for example, they have, like maybe they have the indexes on this side, yeah, or like, for example, they just have array, they don't have the type. Now, of course, like if you do the wrong syntax, like probably they're not going to give you the mark. I mean, like certainly if you don't have the type. So yeah, I mean, I'm just following the syntax they use in the pseudocode guide, or yeah, I guess the syllabus. Right, two global variables contain the minimum and maximum acceptable weight for each component. The values represent an inclusive range and are declared, let's say, well, min, max, both going to be reals. The program uses a variable this index as the array index to access a record. Write a pseudocode clause to check whether or not the weight of an individual component is within the acceptable range. Right, okay, so I guess here what we just want to say if batch, and that's going to take what this index as a as the array index, and then what is it we want the weight? So yeah, I'll see that weight here coming from this I guess you get kind of record declaration. So let's just try and write this. All right, we'll just go if, and this is going to be batch. Right, the index is going to be this index. Right then here, remember we have to go dot weight, right, if we want to access a specific field or a specific property of the record. Right, so let's say if this is greater than or equal to, so yeah, greater than or equal to min. Let's also go and what batch. So I'm just going to do the same. So again, it's obviously going to be dot weight, right, and then that's going to be what less than or equal to max. Yeah, I think that should be fine. Like maybe we need the then, but yeah, I don't know. Maybe that's necessary, or maybe it's not. Right, so when batches of less than 1,000 components are processed, it's necessary to indicate that certain elements in the array are unused. Right, we want to state how an unused array element could be indicated. So here, I mean, we want to think, well, what field can have some like default or sort of empty value? And I think, I mean, the logical one is, well, just set the item ID just to be an empty string. So yeah, I mean, let's just say that, right? The item ID, right, could be set, maybe set to, could be set to an empty string. Yeah, okay. I mean, so obviously, like when we say empty string, I mean, I think people know what that is, right? Just quotes with obviously no characters inside. Right, a module in range. This will be called when an integer parameter is representing an index, right, value of a record in the batch array. It's going to check if the weight of the index component is within the acceptable range, and returns true if the weight is in the range, or false if it's not. I mean, so that's basically what we've just done, but just sort of putting that inside a function. Right, then a module batch check will iterate through a batch of 1,000 component records, call module in range to check each individual component record. Right, then it will keep account of the number of components that fail, and output a suitable warning message and immediately stop if the number of failed components exceeds 5. Right, okay, so yeah, let's think about this then, because well, what we want to do, we want to complete a flowchart. So if we see here, well, obviously, I mean, this part is going to be looping, because yeah, we see this is coming back. So like, what do we want to do first outside the loop? And usually this would just be some like initial declaration. So right, let's think what we wanted to declare. I mean, I guess one is going to be count, and then yeah, we probably also have. Yeah, we probably have an index. So let's just declare, I guess, yeah, let's initialize both of those. So if we go set, let's go set count, right, to 1. And again, again, this is just going to be the same, right, set index to 1. Right, then, yeah, what do we want to do first in the loop? I mean, this could be incrementing the index, but maybe here, like, we can try and complete these other ones first. And then yeah, whatever we have kind of remaining, right, we can then do the increment at the end. Because obviously the thing is, you could increment the index right here at the start, or you could increment the index kind of at the end. Yeah, and hang on, right, I guess so count should actually be 0. Okay, count shouldn't be 1, but the index should be 1. Although I guess actually here, right, okay. So yeah, here, right, if we're incrementing the index in this position, right, then the count should be, then the index should be 0. So I think, yeah, that's why, I mean, let's try and do this one first, right, then we can determine where the increment kind of has to go. So I think this one can be when they call in range. Yeah, because like, okay, so if I guess if it is in range, well then it's just going to go yes, right? And it's obviously just going to loop back right to the next element. So I suppose yeah, here then this is where we have to increment the index. Right, so yeah, set index to index plus 1. And I think, to be honest, for flowcharts they do also allow you just to go increment. So yeah, if you just write increment, and yeah, if we just go increment index like that, okay, I think yeah, they also accept increment and decrement as well. Right, so here what do we want to check? We want to check, so is, and this will be, is it what, in range? I mean, does that take any parameters? So I guess, okay, right, so it's going to be called with an integer parameter. Alright, so this is going to be what, in range index. And right, well, if that equals true. Yeah, so I guess right, if it equals true, right, it's going to go back. Right, if it's false, then what do we want to do? We just want to increment the count. So alright, I think in this one, let's use increment then. And you know, of course, like we can think, well, since this one, you know, it's the rectangle, so because it's a rectangle, well, that means it's going to be process, right, or sequence. Right, the next one, so a diamond, that's going to be another if statement. So what else do we want to check? We want to, so this one, I think, right, immediately stop if the number of failed components exceeds 5. So let's go is, yeah, because obviously, so this is going to be yes, right, if it kind of fails. So right, let's go is, and that's going to be, right, we called it count. Right, count, and is that greater than 5? Right, then, yeah, if it is, well then, yeah, what do we output? So let's just output like too many failures. Alright, and then I think, yeah, okay, so I think now we've got everything. But I guess let's remember also just to put the no on this one. Number 4 says a procedure 2 parts will input a sequence of real values one at a time. Right, the procedure will process the sequence in 2 parts and form a first total by adding the values until the first 0. Right, then form a second total by adding the values after the first 0 until the second 0. And then output the average of the 2 totals together with a suitable message. Right, values input in the first part are total using a global variable total A, and those input in the second part are totaled using a global variable total B. Right, so what this is saying is, for example, let's imagine we have the input, I don't know, 4, 7, let's say 0, maybe like 3, 5, right, 2, and then another 0. Well, of course, what that's going to do, the total for this part is going to be 11. Right, then of course we see a 0, so now it's going to go to the second sequence. What the total of that is going to be 10. Then of course we see another 0, right, so here then we just stop. So yeah, hopefully you can see, I mean, we can do that just by having 2 loops. And yeah, just looping, I guess what looping, like while it's not 0. Yeah, or maybe until they see 0. Right, and then, so here then, of course, well, you can go to the exam questions, right, choose this starter code, although to be honest, yeah, you can easily type this, right, there's only one, yeah, it's just sort of, you know, one statement really. Right, I'm also just going to paste the, paste the instructions. Okay, so let's just go procedure, this will be 2 parts. And here then we don't need any parameters because, well, they've not told us that we do. And then, well, let's think what we need to declare. I guess, I mean, obviously, well, these totals we don't need to declare because, well, they're global. I suppose one thing we need to declare, what is going to be the user input. Yeah, just some variable that we can store the user input. I mean, maybe we can declare average, although to be honest, we don't really have to. Because yeah, we can just calculate and output the average directly, you know, without assigning it to a variable. And I suppose if we are, so, alright, hang on, I'm trying to, think of this. So I'm a bit confused, like when it says average, like, does that just mean like total A plus total B? Obviously divided by 2. Or do they mean like, okay, if there's 3 entries for total A, then you'd obviously do like total A, divided by 3. If there's 5 entries for total B, well, total B divided by 5. I think they just mean total A plus total B divided by 2. If they did want us to do, divided by the sort of count of everything, then I guess we'd also need a count variable, just counting how many valid inputs there are. I don't think that's what it's asking us to do. Alright, so let's just assign total A and total B. We'll just initialize them with a value 0. Because, since this is a global variable, well, if we've called 2 parts before, that's going to have the values total A and total B, as they were in the previous time we called this. So let's just make sure just to reset them to 0. Right, then I guess probably the easiest way to do this will be with a repeat until, right, so a post-conditional loop. And I guess we want to go until the user input is equal to 0. And let's think what we want to do. We can just output maybe enter a number. Let's say like 0 to stop. Right, then we're just going to go input, and we're going to input that into user input. And I suppose we also want to add this to total A. Right, okay, and then, honestly, like the next one we can just copy that. I think input again, and then of course, well, that's going to be total B. Right, that's going to be total B. Right, then we just want to output an average, with a suitable message. Okay, so I think the only thing we want to output then is going to be the average. So if we do just want to use this average that we've kind of created, let's go, total A, right, plus total B. Right, then we want to go divided by 2. And notice that in this case we actually do need the brackets, because if we did total A plus total B divided by 2, well, thinking the order of operations, right, sort of BODMAS, or whatever you want to call it, that would obviously do this one first, right, then it's going to plus this. Of course, well, in this case we do need the brackets. And let's see what average of both sequences is. Right, and then let's just go average like this. Right, so I think that should be okay. Then if we just want to test this, well, let's call it, since it's a procedure. I'm just going to move that across, and then, well, let's just see. So let's enter, well, I think we said 4. In fact, let's choose something easy. Let's go 4 and 2. Right, then let's say 0. And then let's choose something like maybe 7, and let's choose, 7 and 3. Or maybe 7 and 4. Right, then let's go 0. Alright, so that's 8.5. I don't know, is that correct? Right, so we've got 6, then we've got 7, 13, then we've got 17. So I guess 17 divided by 2 is 8.5. This seems to be working. Right, then the next one, the value 0 denotes the split between the 2 parts of the sequence. The requirement changes now, and then maybe up to 20 parts. Right, identify a suitable data structure that could be used to store the total, the different total values. Right, so rather than going, total A, total B, total C, total D, of course we can just have an array. And this one is weird because, when you say data structure, well, you just say let's say an array, a record, something like, let's say a linked list. But, since this is 2 marks, I think they actually want us to be more specific. I did actually check the mark scheme for this, so they want to say, array of 20 reals, or 20 real numbers. Which is a little bit strange because, if you just say data structure, well, the data structure just means this. Obviously this would be, let's say, the size, right, all the dimensions. I guess, the size really, and obviously, this would be the data type. So I think really they should say, the data structure and type. Then of course it would be more obvious what you need for the 2 marks. Right, then let's describe 3 benefits of using the data structure given in, this part. So I guess one, well, we can easily loop. Okay, well I think one thing I can say is we only need one identifier, right, rather than 20 identifiers. Yeah, okay, right, we only need one, or we could say what, to declare one identifier. I guess what, declare / reference one identifier. Yeah, like rather than 20. Right, I guess the next one, well, we can loop through it, or yeah, we can loop through and access elements based on an index. So I think, all right, let's say, yeah, we can loop through. Okay, yeah, we can loop through all elements, right, based on an index. And I mean, well, let's just explain why that's useful. So I guess what makes searching, sorting easy. Yeah, I guess that's okay. I mean, for the next one, maybe we can just say like less duplicate. I don't know, yeah, like less duplicate code, or kind of like a shorter file. Yeah, so maybe let's say right less lines of code. And I suppose you can say, well, that's an advantage because obviously it's going to make, let's say, making changes would be easier because again, we only have to change it in one place, right, rather than changing it in 20 places. Right, so let's say, yeah, makes code easier to understand. You know, I mean, I feel this is similar to point one, but yeah, hopefully they're going to be two, you know, distinct points. Right, easier to understand because we have less duplicate. Yeah, because we have less duplicate code. And I suppose we can say, well, easier to understand. Let's say, right, and modify. Now, I think another one, like sometimes they give for number 4. I mean, you can say, well, you can access each element in an array by an index. Because let's say, for example, I mean, like this example, maybe you wouldn't want to. But let's say, for example, you have like, I don't know, let's say like an array of people and you want to access a specific person. And, you know, let's say each person has like an ID number, right, which is the index. Now, you wouldn't like, okay, if you were doing, you know, where you actually create 100 different variables, like, you know, person 1, person 2, person 3, well, you wouldn't be able to say ask for user input, and if they sort of input 5, you know, you wouldn't actually be able to get like person 5, like unless you literally had an if statement with like kind of what if user input equals 1, right, then, you know, we'll get person 1, right, else if user input equals 2, right, then, you know, get person 2. Of course, you do with a case statement as well. Whereas, obviously, with an index, right, well, of course, you can just do something like this. So, of course, well, here you have the input. Let's say what input, I guess what just input index. Then, of course, we go, well, person index. And let's say, for example, we want to assign them like a new name. We can, of course, just go name, and then this will be what just like the name that the user input, for example. So of course, yeah, using an index, well, we can access like any element in the array. I guess, you know, without needing like a huge if statement, right, or a huge case statement. Okay, number 5, a program is being designed in pseudocode. The program contains the following declaration. Alright, so more arrays. So it's going to be data. Right, it's going to be 1,000 elements of type string. A procedure array initialize is written to initialize the values in the array. So yeah, let's read through this first. So procedure, it's going to take a label, that's a string parameter. Then we're going to declare an index, which is an integer. We assign the index the value of 1. Or yeah, we initialize it with the value of 1. Right, then we're going to have a while loop. So while index is less than or equal to 1,000. Then we have our case of index mod 2. So if we think, I mean, this is basically checking if it's even or odd. Because, for example, if we have, well, let's say, for example, well, 2 mod 2, well, 2 mod 2 is going to equal 0. If we have, you know, 3 mod 2, well, 3 mod 2 is going to equal 1. Of course, yeah, 4 mod 2 is going to be 0, right, 5 mod 2 is going to be 1. So yeah, this is another way if you can check, right, if a number is even or odd. Right then, I guess if it's 0, they're just going to call this format A, right, and again takes an argument or a parameter label. Yeah, just assign that to the data right at this particular index. Right then, just increment the index. Likewise, if it's 1, well, it's basically the same, but they just use format B, and again, then just increment the index. Right, functions format A and format B apply fixed format changes to the parameter string. Okay, so yeah, I guess that means it's going to be the same every time. Right, the design of the procedure does not use the most appropriate loop construct. Suggest a more appropriate loop construct. Yeah, that could be used and explain your choice. So I suppose here, because we know the array has 1,000 elements and we want to loop through all 1,000, well, I mean, you may as well just use a for loop. So I mean, let's say for loop. And often, yeah, they want us to give the sort of general name, right? So that's going to be count controlled. And I mean, hopefully you can remember the other one, right? So pre-conditional is going to be a while loop. Post-conditional, well, that's going to be the repeat until. Then of course, yeah, count controlled, that's going to be the for loop. So the explanation, we can say, I guess what we know. Okay, well, let's say, yeah, I guess, well, let's say we know. Right, we know how many times to loop in advance. Yeah, how many times, right, we need to loop, right, in advance. And let's say in brackets, right, 1,000, right, since, well, yeah, since the array has 1,000 elements. Right, the algorithm calls one of the functions format A and format B each time within the loop. Right, explain why this is not efficient and suggest a more efficient solution. Now, I mean, this is actually a complex question. And to be honest, when I first saw the paper, like, I mean, honestly, I was thinking, well, you could actually sort of copy the code. So like, rather than actually calling the function, you would actually copy the code from inside the function, and then just sort of, yeah, directly paste it, inside this case statement. And I mean, that's actually a compiler optimization that it's called. Yeah, well, I guess what function inlining. So like, I mean, if people are curious about that, yeah, right, okay, I think that's how you spell it. So if people are curious about function inlining, well, of course, yeah, just, go online, right, you can search it. But, to be honest, I was thinking that was a bit too complex. So if you actually look at this, you have to think, well, right, here we have this label parameter. Now, actually, label is never updated here. So what that means, and also here it says, right, fixed format case changes to the parameter string. So if we have I don't know, let's say the label is like, say ABC, well, that's always going to convert this ABC, right, to the same output. So what we could actually do is, well, we could actually store this in a local variable here. For example, we could have one for, I don't know, yeah, like format A result. Okay, we could have another local variable for format B result. And then of course, like, rather than saying format A function, let's say what, like, the FA, right, local variable, right, and that's let's say what, yeah, the format B, right, local variable. So yeah, let's try and say that. So we can say maybe since, right, since the label, yeah, I guess what, the label argument, right, or parameter. I think let's say argument here. And like, I mean, yeah, okay, let's just explain the difference between arguments and parameters. Now, I guess, like, when you actually see it here in the function header, or, well, in this case, the procedure header, right, the module header, well, this is going to be called a parameter. But when we actually use it, so I'm just going to call it AI, right, so this array initialize, and let's say this is just ABC. Now, when we actually use a specific value, well, this is going to be the argument, because obviously in this case the argument is ABC, but we could also call it again with like DEF. So effectively, yeah, this is going to be one example of an argument. Of course, this is another argument, but the parameter is always just called label. So yeah, that's just the difference, right? The parameter is the actual sort of, let's say, the name of the identifier, whereas yeah, the argument is actually the specific value that we're sort of passing to the parameter. Right, so let's say, yeah, since the label argument is not updated, yeah, let's say, right, since it's not updated, right, and yeah, let's say the format functions, right, provide fixed changes. Right, yeah, since they provide fixed changes, then I guess what then the result will always be the same. Yeah, so I guess we could say what instead. Yeah, because I mean this is also right suggest a more efficient solution. Right, instead we could let's say declare let's say what declare two local variables. Right, okay, two local variables to store the answers. Or well, maybe the results, right, to store the results of calling, let's say calling each function. Yeah, and then let's say, right, and use these in the case statement instead. Or, yeah, maybe, right, and use these local variables. Right, let's say, and use these local variables to maybe what assign to each array index, or yeah, to assign to right the array index. Well, I guess well, not really the array index, right? Let's say the array element. Okay, and then I mean, hopefully that's enough. Maybe we can explain why it's not efficient a bit more. So we can say what this ensures the function code only has to be called once. Of course, you know, obviously one for format A, one for format B, right? And also doesn't require the overhead of like calling each function, because I mean, like if people know like when you call a function, well, there's going to be a few things that have to happen. Like first of all, let's say the return address has to be added to the stack. Yeah, I think the the local variables, right? They also get pushed onto the stack. Yeah, the parameters, right? They also get passed. So all of this has to happen, and then you know when the function returns, well, all of these things then get popped off the stack. So basically, yeah, just like popped out of RAM. So yeah, maybe we can mention that. Right, this let's say ensures right the function. Yeah, let's say the function code. Let's say right the function code for each function is only executed once. Right, and then let's also say, yeah, maybe and. And I suppose we can say, yeah, like and doesn't unnecessarily kind of, yeah, like push and pop things from the stack when calling and, yeah, unwinding or returning from functions. Yeah, I mean, like this is going to be quite long. Okay, but let's say, right, doesn't require, or let's say repeatedly. Yeah, or let's say while pushing, popping. Yeah, I don't know, let's just say, right, things to the stack. Right, things to the stack. Yeah, let's say each function call. And I mean, yeah, obviously that's quite a lot, so hopefully that's going to be enough for 4 marks. Question 6 says a program displays a progress bar to inform the user of the progress of tasks that take a significant time to complete, right, such as those involving file transfer operations. Task progress is divided into 11 steps. Each step represents the amount of progress as a percentage, and an image is associated with each step, and each image is stored in a different file. Different progress bar images may be selected for a given image. Files all have the same file name root with a different suffix, and the table illustrates the process for using the image with file name root, well, bar graph A. Okay, so I mean, obviously, what that's saying then, well, the root is obviously this part, and then the suffix is going to be this one, and I guess they all have this hyphen as well. Right, so if the percentage is less than 10, right, then it's going to give us this step 1 image, right? If it's what, I guess what, yeah. So I think here we can say, well, if it starts, let's say 10 and 2, let's say 19.9999, because is it a real or is it a Yeah, I'm not sure. I guess actually, so the next one says it's an integer. So effectively saying what 10 to 19, right, that's going to be, yeah, this 2. Obviously what 20 to 29 is therefore going to be 3. Right, a procedure progress will be called with 2 parameters, an integer representing the percentage progress, right, 0 to 100, yeah, inclusive. Right, then a string representing the file name root, and we want to generate the full image file name and call a procedure display using the full image file name as the parameter. Okay, so we want to write pseudocode for procedure progress. Yeah, and in fact, hang on, let me just copy these instructions here. Alright, so again then, obviously if you go to the exam questions, well here I've just provided this starter code. And actually I think this display is actually not required. But yeah, like I just did it just so we can actually test it to see if it's working. And what this display is going to do, it's going to take a file name, right, and then basically it's just going to display sort of a representation, basically just made up of what either sort of green squares or black squares, yeah, just representing, let's say the sort of percentage it's loaded. Right, so let's just paste those. Okay, and yeah, for some reason it's copied a load of other stuff. Right, okay, so we want to go procedure, and that's going to be progress. Right, then so it's going to be called with 2 parameters. Let's say, I don't know, maybe let's say progress amount. Right, that's going to be an integer. The next one, right, so I guess the root or the file name. Yeah, let's say, well, maybe like file name root. Right, that's going to be string, and obviously since it's a procedure, well, yeah, it's going to be no return type or no return value. Right, then we want to, okay, so well, then we just want to generate the full image file name. So what we have to think is, well, how do we convert, say, like 75, right, into, well, that's going to be 80 in this case. So I think, you know, one way we can do it, one way we can do it is if we use div. So, for example, let's try, yeah, I'm just going to draw again. Like, let's think if we have, say, the value of 75. Now, what we can think is, well, here there's going to be a gap of 10. So if we go, what, 75 div 10, well, that's going to give us the value 7. But if we actually look, or, okay, well, so I think let's try 95, yeah, since we can see this example. So if we do 95 div 10, well, of course, that's going to equal 9. But, you know, we actually want the number 10. So what we can do is if we just go +1, yeah, this should work. And of course, like, we can also try this one, say 100, because yeah, this is kind of like an edge case. Now 100 div 10, well, that's going to be 10. Then if we just go 10 add 1, right, that's going to give us the 11. And yeah, of course, you can try this for all the others, right, that should work. So yeah, okay, and then what we also, right, we want to call a procedure display. Right, so let's actually go declare, and I guess here we can declare the final file name. Right, that's going to be a string, and then yeah, I don't know, like, is there really much we need to do? Because I think we can do most of this, you know, all just in one line, to be honest. Maybe we can also declare, and this can be the sort of file number. Yeah, I mean, let's call it file number. So again, that would be sort of, well, like 1 right up until 11. So let's try and calculate this file number. And right, that's going to be and so let's put this in brackets. Right, that's going to be the progress amount, right, div 10. Then we just want to go add 1. Then in order to calculate the final file name, right, that's going to be what the file name root. Then it's going to be and the this hyphen. And then we just want to go and I think here actually, if we're concatenating, so if we're concatenating with an integer, then we should actually get, well, num to string. Right, that's going to be the file number. And then what it's going to be so concatenate, and then what is a bitmap, right, BMP. Yeah, okay, BMP. Right, and I think, I mean, what then we just have to call, so let's go call display, and this is going to be, yeah, the the final file name. Yeah, I mean, I don't know, like to me, you know, when I have code that's this short, I always feel like, well, did I miss something? But yeah, I'm pretty sure that's all we need. Right then, if we just call this, so let's go progress. Let's say the amount is what, like 95? Or in fact, well, let's start 5, right, something small. And I suppose this one, it doesn't really matter. I mean, let's go bar graph. So let's just run this to test it. And yeah, okay, so 1, we get nothing, which I think is what they have here. Yeah, so if we have, so image 1 like this, right, that's just an empty, yeah, kind of empty image or empty bar. And then, I mean, well, we can just test this. So let's call it in a loop. Or, for example, we could try 100. So 100 should be, you know, 100% full. Yeah, so saying bar graph 11, right, 100. And then if we just want to test it, well, let's just put it in a loop. So let's go 4. I guess we can call it n. Right, let's go 0, and that's going to go to 100. And let's just go right next n. And I think what I might do is, yeah, I might just also go output n, just so we can actually see, you know, what number this is for. Right, and then yeah, let's make that n, and maybe here let's just output some sort of spaces between them. Right, so yeah, 0 is like this, and then hopefully when we get to 10, yeah, okay, then 10 it goes like that. So we have 1, right, then 2. And then if we go to, yeah, 99 is like this, right, then 100, yeah. Alright, so this one seems to be working now. Right, then part B says the definition of procedure progress is provided here for reference. Yeah, just repeated, right, progress will be rewritten on a new module progress 2, produced with these requirements. Right, an additional parameter of type integer will specify the total number of steps. The additional file name will be returned. Procedure display will not be called from within progress 2. Right, okay, so the image file name will be returned. Right, okay. So what this is saying is, well, rather than having like 11 steps, I guess what 0 to 10, or what sort of, yeah, what greater than or equal to 0, less than 10, what, yeah, greater than or equal to 10, what less than 20. Rather than having like 11 different steps, you know, maybe you have 100 different steps. So then each one is going to be what, like 1%. Right, so new right, pseudocode for this new module header, well, it's going to be a function because it says the file name will be returned. Right, then it's called, well, progress 2. Right, then the, okay, so I guess, well, first we need these parameters. So let's go, I guess, what, progress, or yeah, progress amount. And I think, I mean, here we can do the steps here, you know, we don't really have to keep the same order. So yeah, I mean, let's say it's steps, or yeah, like number of steps. Right, both of those, they're going to be integers. Right, then we have what, the root file name. So let's just do that again. Okay, root file name. And yeah, let's say that's going to be a string. Right, and then we just want to say what it's going to return. So let's go returns. And then yeah, here it's going to be a string. Since if we see, right, the image file name will be returned. Right, state one benefit of increasing the number of steps. So I guess here you can say what it's going to more accurately represent the current progress. Also, it's going to update more frequently, because otherwise you might have it where, let's say it's on like 80%, and then of course it's just going to wait there for like, I don't know, maybe a couple of minutes, right, maybe longer. Then of course it's just going to instantly jump to sort of 90%. So yeah, like in this case, like maybe the user would just think that their download or, you know, installation is just frozen. So what we can say, maybe to more accurately represent the current, yeah, okay, let's say, right, more accurately represent the current progress. Maybe the current progress amount. And I mean, yeah, I think that should be enough. But like, if we just want to expand it, well, let's say, like, due to, I don't know, smaller, let's say smaller gaps between the steps. I guess, well, not between the steps, maybe smaller gaps. let's say between, I don't know, I guess what, sort of, well, between each range, or just, yes, let's say smaller ranges. Alright, let's say smaller ranges for each step. Right, okay, so 7 program modules form part of a program. A description of the relationship between the modules is summarized below. Right, any return values are stated in the description. So module A calls module B followed by module C. Module B, right, called with parameters, well, P1, P2, right, parameter 1, parameter 2. Right, so it's going to call D or E, determined when the program runs, and returns a Boolean value. Right, mod C called with parameters P1, P3. P3 is passed by reference, and it's going to repeatedly call F and G. Right, then D is called with, well, parameter 2. E is called with parameter 3. Right, returns an integer value. Right, F is called with parameter 3, and G is called with parameter 3. And again, parameter 3 is passed by reference. Right, so right, parameter 1 and 3 are strings, and parameter 2 is of type integer. Okay, we want to identify the modules that would be implemented as functions. So I think here then we're just looking for, well, when does it say return? So I guess, yeah, that's going to be B. Right, it's also going to be E. And I mean, yeah, like if you just read the others, I mean, there's nothing that sort of indicates they're a function. So yeah, let's just write what mod B, and then also what mod E. Yeah, okay, E. Right, modules, well, F and G are both called with parameter 3 as a parameter. In the case of mod F, the parameter is passed by value. In the case of mod G, the parameter is passed by reference. And we want to explain right, the effect of the 2 different ways of passing parameter, right, well, parameter 3. Right, I mean, so I'll try and explain this, although this probably won't be a good explanation. So let's say, for, which one is, so, okay, right, so F is passed by value. So let's say when we call F, and what is the, okay, well, let's call it P3. Now, what we can say, I mean, well, like this is obviously going to be somewhere in memory, and let's say, for example, P3 has the value, what is it, a string or an integer? Right, okay, it's going to be a string. So let's just say that has the value, I don't know, like A, right, I guess, yeah, just a character, right, just a string. Now, when, and I don't know, like maybe in here we just go P3 and we just update it, let's just make this B. Now, if we do pass by value, then what happens is, well, when we actually call this function, so for example, like let's say here we just, well, go call, and yeah, obviously we can have another, maybe let's call it X or something, right? This can be our actual kind of argument. Now, of course, like let's say, well, this X, right, this X is actually going to point to this address in memory, and I don't know, let's say this can be address 1 in memory, right? It doesn't really matter. And then what's going to happen is, well, when we call this, and actually, okay, hang on, this is a procedure, right? Yeah, I think it's procedure. Okay, so when we call this procedure, then when we actually pass the argument as a parameter, well, then a copy of this argument, or yeah, a copy of this parameter is going to get created. So effectively, like now we're going to have another copy of this. Let's say this is a memory address 2. I mean, in reality, you know, this would be somewhere like on the stack, right, in RAM. So effectively, like now we've actually got sort of 2 distinct like memory addresses with this value. And then what happens is, well, now when we, and so what's going to say, let's say, yeah, this P3 is obviously pointing to this one. So then, like when we're updating P3 with this value B, well, of course now it's going to be this one that changes to B. But yeah, if we just do a different color. But of course we see, you know, this original A, yeah, or of course, well, this original like X variable, you know, this is still going to stay the same. So effectively what we're saying is, well, the let's say the value is only going to change like within the function or within the procedure. Whereas if we're using by reference, well, by reference is actually going to update the original variable. So yeah, let's try and just draw by reference quickly. All right, maybe I'll do it here. So again, yeah, okay, I mean, well, let's just do it here because I don't want to rewrite the whole thing. So let's explain how it's different. So by reference, well, we're never going to have this second memory address created. You know, we're just going to directly update this thing. So in this case, well, right, this X, right, and also P3, they both point to this same memory address. So of course, you know, when we then update this here, right, with this new assignment, well then of course, this one gets updated here right in this memory address, because well we see both of them are pointing to the same memory address. So then of course if we update that, then let's say we just output, right then if we go output X, well of course here the output X is now just going to output B. Yeah, I mean, so hopefully that makes sense. So if we just try to explain that then, let's say pass by value. We can say what let's say means, right? Means a copy. Let's say a copy of the data will be created. And let's say like hence, right? Hence, maybe updating this, or I guess updating it or assigning it a new value. Let's say updating inside the module. Let's say like won't affect the, or okay, let's say won't modify, right? Won't modify the original variable. Right, then we can say, let's say what, by reference or pass by reference. Right, so we can say, well, this means we're, okay, right, let's say means, right, we are passing, so we can say, well, we're passing a memory address to the original variable. Right, okay, a memory address, right, to the original variable. And I guess we say what again? Well, hence changes inside the module. Right, hence changes inside the module. Right, will change the original variable. Alright, so let's say the original variable. So again, that's the difference, right? I mean, by value, well, you're basically creating a copy, so the original won't be changed. By reference, well, you're passing a memory address to that variable. Hence the original will be changed. Right, then we want to draw a structure chart to show the relationship between the 7 modules and parameters passed between them. Alright, so since this is quite a lot and it's on a different page, let's just open this in a new window. And I'll try to just have them sort of side by side. Alright. Okay, so I guess if we just start at A, probably we can draw this at the top. I mean, like we could look just to make sure it's the correct order, but what A is going to call B and C. B is then going to call what D or E. C is going to call F, F or G, or F and G. And then I guess what, D, E, F, right? D, E, F, G, they're not going to call anything. So in this case, we can say, well, mod A is going to be at the top. Right, then we say, well, calls mod B, right, followed by mod C. So, I mean, the one on the left is therefore going to be mod B, right, the one on the right, that's going to be mod C. Right, then mod B called with parameters, parameter 1, parameter 2. So I think if we're calling it with a parameter, I mean, let's do this on the left, right, and then let's say the return values here are, going to be on the right. So, right, that's going to be what, parameter 1, right, then there's going to be another parameter, parameter 2. Right, then it's going to call either mod D or mod E determined when the program runs. So when it says determined when the program runs, that means it's going to be an if statement. That's not very good, but I mean, basically, that should be a diamond. Right, so I guess the first one, what it's going to call, it's going to call D. Right, and then here, let's just go what, mod E. Okay, and then and then if we look back here to mod B, well, this is going to return a Boolean value. So a Boolean value, if we remember, well, it's also called a flag, right? Therefore, we should just highlight that, or color in the circle. Right, then, okay, I mean, all right, maybe let's try D first, and then, I guess, or let's just do it in order. Right, let's go C. So C is called with parameters, well, parameter 1, parameter 3. So is that, yeah, okay, alright, so I think the first one was 1 and 2, right, this is 1 and 3. Alright, so actually, hang on, yeah, let me just erase that, because it says parameter 3 is passed by reference. So if it's passed by reference, well, then it's going to need the double arrow, right, the bidirectional arrow. And I think really passed by reference, they would often draw on the right. I think it doesn't really matter, but yeah, I mean, let's just stick to that convention. And you think, I mean, well, the reason it's sort of, on the right is because, I mean, we're not really returning a value, but we're obviously just updating this directly. Right, then it's going to repeatedly call mod f followed by mod g. So I mean, let's just write that then, mod f. Yeah, I think here I'm kind of running out of space. Right, I'm just going to say g because I've got no space. Right, then when it says repeatedly called, well, that means we actually need an, let's say an arrow, right, just to represent the iteration. So what this is saying, of course, well, we do this one first, right, mod f, then we do mod g. Then, of course, yeah, when we get to the end, well, then we're just going to go back and just loop. And, like, I know some people, like, they actually do the arrow this way. And, I don't know, like, maybe they would accept that. But if you actually think what that's kind of saying, I mean, it's just slightly different, right? Because, I mean, here we're saying, well, do this, right, then do this, right, then when we get to the end. Because, I mean, the way we read them is kind of left to right. Yeah, then when we get to the end, we'll then loop back to the start. Whereas, I guess, if we do something like this, let's say, something like this here, like this is almost saying, well, just jump over mod f and g, and just, yeah, sort of go to some other part. So yeah, I mean, I guess, yeah, just make sure to do the arrow the right way. Right, then what have we done? So we've done mod c. Yeah, then if we look at mod d, right, that's called with parameter 2. Right, okay, parameter 2. Then mod e, right, called with parameter 3. Right, and it's going to return an integer value, so let's just draw that. And of course, in integer, we don't need to, fill in the circle. Right, mod f is called with parameter 3. Yeah, I'm kind of definitely running out of space here. Okay, hang on, that should be an arrow. Right, and then g, so called with parameter 3, and again, that's passed by reference. So by reference, well, as we've done before, let's do it on the right. Yeah, I mean, let's try and sort of draw it parallel. And let's go, what, P3. I mean, obviously, that's super messy, just writing on this graphics tablet. But yeah, in the exam, try to make it a little bit neater. And then I would say, when you've done this, I mean, probably just spend 30 seconds just, yeah, going through this whole thing again, right, making sure you've not missed anything. The last question says, a teacher is designing a program to process pseudocode projects written by her students. The program analyzes a student project and extracts information about each module that is defined, right, each procedure or function. This information is stored in a global 2D array mod info type string. A module header is the first line of a module definition and starts with either of the keywords, right, procedure or function. So an example of part of the array is given below. Row 10 of the array shows that a procedure header occurs on line 27, and row 11 shows that a function header occurs on line 35. So yeah, I guess this first one's going to be the line numbers, but yeah, note how this is represented as a string, right, not an integer. Right, P represents a procedure and F represents a function. Right, the string stored in column 3 is called the module description. Right, this is the module header without the keyword. So yeah, rather than saying like, procedure, right, my proc, and then this, it basically just doesn't have the procedure, it doesn't have the space. Right, a valid module header will be at least 13 characters long, will start with the keyword procedure or function. The keyword may appear in either uppercase or lowercase or a mix of both, and must be followed by a space character. Right, the teacher has defined the first program module as follows. So header, this is called with a parameter of type string representing a line of pseudocode. And if the line is a valid procedure header, it will return a string. So we see, well, P, then the module description. Same for function, right, F, then module description. Right, otherwise return an empty string. So for example, well, this function, right, header is basically it's going to return the whole thing. But yeah, just, well, without the function, right, without the space. And of course, yeah, just sort of putting an F here at the start. So, I mean, yeah, let's have a think of how we can do this. And I think, I mean, what we can think about is that, well, basically all we want is we want just these right characters here. So yeah, just kind of removing this function part. And the way we can do that, well, we can use right. We can just count how many characters are in this, function space. So function, well, that's going to be 4, right? That's going to be 8. And then, yeah, with the space, right, that's going to be 9 characters. I think if we do the same for procedure, so, right, that's 4, that's 5, right, that's going to be 9, and then with the space, so procedure is going to be 10. So, like, if we just have a simple example, let's imagine just ABC. Let's say ABC is the equivalent to like the function or the procedure, right? Just the keyword, right? Then we have a space. Then we have, let's say, DEF. Now, if we just want to get this right part, so we just want to get this DEF, well, what we can do, we can take the length, which in this case is going to be 7. Then we just take, well, I mean, so this part we actually know the length of this. This is going to be 4, right? Just like we said, function and the space is 9, right? Procedure and the space is going to be 10. So we do what the length, right? Minus 4. So here, 7 minus 4, well, that's going to equal 3. And then what we're saying is, well, we just want right, that's going to take the sort of line or the string. And then, yeah, 3 will be the second parameter, right, the second argument. Yeah, so I think we should be able to attempt this. And again, of course, we'll go to the exam questions, right? You can choose this starter code. And then, yeah, here we've just got an example project, which, well, we'll use for this question, right, and the next one. Right, so I've just gone ahead and just copied all of the instructions because, well, there's actually quite a lot. And yeah, I'm going to choose this one, right, just the project file. Now, let's say then this is going to be, a function because it's going to return a string. Right, okay, so right here then, yeah, okay, right, so it's called header. And then it's going to take a string, right, that's going to be a line, and it's also, well, let's go return string. Now, let's think about the local variables we need. And since here it says, well, basically this, this function procedure, this can be lowercase, uppercase, right, or a mixture. So I think what we want is, well, we want to convert this to one particular case. So let's say probably we can just convert the line to uppercase, but we actually don't, I mean, like, okay, I mean, let's say, like, we don't want to modify this line directly, because, of course, then that's going to actually convert the whole thing, right? So, like, if we have, say, this zap x, like, that would also convert this AP, right, into uppercase as well. So let's make another variable, kind of like a temporary variable. Let's call that line upper. That can be string. And yeah, I think for this case, right, that's probably all we need. Now, the first one it said, well, if it's less than 13 characters, or I guess we can say that a valid line has to be at least 13 characters. So, I mean, we could do it where we could say, let's say if length of line, right, 13. If length of line is less than 13, like then we could just go return false. So, I mean, yeah, that's one way you can do it. But I think we can kind of invert that logic where we say, well, if the length of line is greater than or equal to 13, of course, this is where it's valid. Let's have an end if, and then so inside here, well, this will be if it's a functional procedure, and then if we just go to the end, let's just go return empty string, and this will be multiple cases. This will be, well, 1, right, if it's less than 13 characters. It's also going to be, well, if it doesn't match any of these if conditions, which we'll make inside here. And of course, if we haven't returned already, like inside this if statement, yeah, then it's also going to go here. Because you imagine, we could have a line, let's say, for example, output. Like, let's say, yeah, please enter your name. Well, of course, this is going to be longer than 13 characters, but it's still not going to be a valid function, or yeah, it's not going to be a valid procedure. Right, so I guess we're having to, I've declared this line upper, but I've not actually done anything yet. So, I mean, let's probably do it here. Let's go line upper. And then here, let's just go right to upper, and that's going to take line as the parameter, right, the argument. Right, then I suppose let's check if it's a function. So, I mean, for this we can use left. So let's check, right, if the left and what we said, 9. Right, so yeah, if the 9 leftmost characters is function and then a space. And notice how we do need the space, because if we say function but like ABC, well, now if we have no space, of course, this is not actually considered to be the function keyword. This would actually be interpreted as, well, let's say an identifier, like a variable, or yeah, function name or something. Whereas, yeah, of course, if we have the space, right, well, then it's actually the keyword. Right, so if it is function, well, then what we want to do, I guess we just want to return. And notice, well, we're going to return f because, yeah, here it's going to start with f. Right, then this is where we want to return what sort of the rightmost, yeah, I guess, well, all of the characters, right, except the 9 leftmost characters. So here then we can just use right, and that's going to take, yeah, that's going to take line. Right, and then we just want to go what length, and that's going to be, yeah, right, hang on, right, that's going to be the length of the line, right, and then just, well, -9, which I think is what we said. Right, I'm going to copy this because, well, the procedure one will be kind of almost identical. And yeah, let's make sure not to forget any of the endifs. Right, so for procedure, I think we said there's going to be 10. Right, that's going to be procedure. Again, yeah, have the space. Right, that's going to be 10, and then I guess here this is going to be p. Yeah, so I think that's everything, right, if we just make sure to end the function. And then, right, I guess now then let's just test it, so let's go output. And I'm just going to test it with their example they've got here. Okay, right, that's not suggesting for some reason. Yeah, if we just run that, and yeah, okay, so this seems to work. Let's try the procedure as well, and I guess we can sort of keep it the same, to be honest. Let's just remove that returns, and then yeah, so that's saying p, right, procedure. Right, then the next part, a new module is required. It's called find modules. It's called with a parameter of type string representing a student project file name. It's going to use the module header to check each line of the project and assign values to the mod info array for each module declaration in the student project. Right, as a reminder, the previous example of the array, right, is kind of repeated below. Right, then write pseudocode for the module find modules, and we can assume that the array contains enough rows for the number of modules in each project. Alright, so again, let me just copy the instructions here. Okay, alright, there we go. Right, I'm just going to hang on. Right, I'm just going to comment out this output. Okay, so this said it was a procedure. Right, so procedure find modules. Now, right, this one is called with a parameter of type string, right, file name. So let's call that file name. That's going to be a string. And then let's think, well, what local variables do we need? Now, if we're reading from a file, we're going to need a line. So let's make that a string. And then I guess, yeah, like maybe we would want a variable to store the output, or well, to store the return value, right, the result of calling header. So I'm not going to call it header because, well, we already have this called header. Let's call it header value. Although I think this one we wouldn't actually need. You know, we could just update this line. Right, then, if you think if we're adding to the array, well, we're also going to need the index we're adding to in the array. And then, yeah, is there anything else we need? Okay, so I guess if we look here, I mean, this p is fine, right? Yeah, this one is fine because, well, that's coming from the line. But then I guess this one, right, 27, well, that's going to be the line number. So yeah, we're also going to need to store the line number. Now, if we think about initializing them, well, the index we can start at 1. I guess, yeah, the line number, right, we can also start at 1. I mean, you know, this one we can start at 0 if we want. Same with the index, we can also start at 0. It just depends, like if we increment them, if we increment them, you know, before we sort of add this to the array, yeah, or after we add to the array. Right, so in order to read a file, well, let's go open file. That takes the file name, and then we go, well, for, right, then it's the mode, so either read, write, or append. Right, this is going to be read. Right, then in order to loop through a file, again, I mean, we've seen this many times, I think, while not end of file. Yeah, that takes the file name. Right, I'm gonna have the end while just so I don't forget. Then here, then, well, let's read file, and we want to read this file name, and we're going to read that into this variable line. Right, so this means, well, line will just store the current line. Right, then I guess, yeah, so I think then what we can just call this header, and we want to check that it's not an empty string, because, well, if it's an empty string, right, then it's not a valid header. So yeah, let's go header value, and we'll just assign this the output of header, or well, the well, I guess the result of header. right, that's going to take this line parameter. And then we can just say if, so if header value is not equal to an empty string. And of course, like another way to do this, we could say, well, if the length of header value is greater than 0. Right, well, then what do we want to do? So we just want to add this to the mod info. Right, and then what that's going to take, that's going to take index as the column, index as the row. Right, then, well, let's go column 1. Now, column 1, this was the line number, right, if we just look here. So note though that obviously this line number is going to be an integer, but we need to convert to string. So let's go num to string, right, that's going to be line number. Right then, I'm just going to copy it because it's going to be quite similar. Right then, 2, and let's go 3. Now 2, if we think, well, so here then, this is going to be the first character of the header. So in order to get the first character, well, either we can use left, right, or we can use mid. That's going to be line, and then we just want, well, 1 character. Then this one, well, here we want all of the characters except the first character, because, for example, here, like, well, this is where we would just want this zap, right? So yeah, just not including this f. Right, so here, well, let's go right, and similar to how we did it before, let's go line, and let's go what is going to be the length of line. Then just -1, right? So just don't include that first character. And then let's think, well, if we add something to the array, well, then we need to increment index, so that obviously, well, the next time it's then going to add to index 2 in the array. And then here, let's also think we need to increment the line number. So I think that should be okay. Then if we just make sure to close file, right, that's going to be file name. Right, is there anything else we need to do? So yeah, we call the header, we assign values. Yeah, so I think that's okay. Then if we just get, end procedure. Now the thing is, like, if we just call this, I mean, we're not actually going to see anything. So let's go, right, find modules, and I think if we use this file, right, rixcode.txt. And I mean, well, let's say if people are curious about this, I mean, they can, well, of course, they can find it here, right? They can also find this one on the search page. Basically, I mean, this project is just something that can pass subtitles. So if people know, like, SRT, subtitle files, this program can just pass that and display it. And I guess this example is obviously, well, just a Rick roll, right, playing the Rick Astley lyrics. Right, so let's call that, and then what I'm going to do, I'm just going to have a for loop, just so we can actually output the output the contents of this mod info. So let's go for it. Let's go index. That can be 1, and let's go. I think here I've just said 20, just as an example. Right, and then let's go next index. And I think what we can say, I mean, we don't want to output the empty indexes. And of course, this is just for testing, right? I mean, you don't have to do this in the exam. So we don't want to output the, well, let's say empty array elements. So let's go mod info, let's go index, and we'll just check if column 1. So if this is not equal to an empty string, well, then we want to output it. And I think what I'm going to do, so the first one is going to be line number. So let's go mod info, let's go index. This is 1. Right, I'm just going to copy this. Let's have something like this. Then let's go 2. Let's then just kind of output column 3 like that. And I mean, hopefully, if there's no mistakes, this should work. Okay, so here it's then got what procedure on line 56. I mean, like, if we, like, alright, so what I'm going to do, I'm actually just going to copy that and put this here, then I guess we can easily see. Right, so 56, 56 procedure place subtitles, I guess 76, read subtitles, 89, okay, and that's got the index integer. Right, let's try like 148, because that's going to be a function, just check that's also working. That's going to take, so it's going to take a string and it's going to return an integer. And as we can see again, right, it's going to take a string, return an integer. So I think that's the last question. I mean, let me just check. Okay. Alright guys, so as always, I mean, hopefully this video is useful. Any questions, ask in the comments, and if the video was useful, then see you again in the next one.